Okay, welcome back. Actually, we will continue this from the first session. In the first session, we have just tried to understand some aspects of mixed method research and in which direction it is moving. Mixed method research is still a new phenomena yet to be consolidated, but we are seeing the rapid application of the mixed method in the socials, particularly in the social science, particularly in the field of, say, social work, sociology, anthropology, psychology, behavioral psychology, industrial psychology, educational research, in the field of earth science, geography, in the field of economics, field of management and business administration. We are seeing application of mixed method research. And probably there will be two developments in the near future. One with regard to adoption of this mixed method in applied format, and number two, purification of the method in itself. So there will be researchers who will be adopting mixed method research as it is, and there will be another group of researchers who will continue to purify the entire part of this particular method. So in the second session, to continue from the first session, we took up a very brief part in the first session with regard to the data analysis and the challenges that are involved in the data analysis in mixed method format. Because we have understood one thing in the first session, that in case of a mixed method, to a large extent, and even if we consider the timeline up to almost 2013-14, we did not have analytical integration or analytical intersectionality in this mixed method application. So that was one of the drawbacks that were repeatedly pointed out by the researcher, because the researchers did not have enough tools and techniques and know-how with the help of which they could have ensured intersectionality at the analytical platform. However, they ensured integration or intersectionality at the methodical level, at the paradigm level, at the data collection level, and the inferential level. So let us look into some of the challenges in the data analysis in mixed methods format, and how that data analysis, how those challenges have been addressed, and how the future will look like in terms of this data analysis, particularly from the context of mixed method format. So we will be looking into this, and at the end of this particular session, I will try to show you one or two hands-on applications of how these challenges can be met with, particularly in the context of mixed method format. So let us just progress with the slide, and then we will take up the hands-on part later. So, this is nothing new to you, because we know that in the mixed method, two different kind of data structure are analyzed. One, which is a pure numerical data, quantitative data. It looks like this, particularly if you are taking data with the help of a scale, it throws up a matrix, it looks like this. And when we talk about a qualitative data, more often than not, we talk about this kind of a data, which is represented in the form of a text. So it can be an interview transcript, it can be a narrative, it can be a story, it can be anything which represents a text, which can be represented with a text. But qualitative data is not limited in this format only. It can be images, it can be videos, it can be audio. So there can be a variety of data which can be abstract or subjective or qualitative in nature. So if you see, there is a fundamental difference between these two data structure. Now, if you see the quantum of quantitative analysis and qualitative analysis, like the analytical techniques that we are having, if we see the quantitative analysis, if you try to understand the different techniques, we have the frequentist parametric statistical analysis, which the researchers often use. We have the frequentist non-parametric statistical analysis. We have the Bayesian statistical analysis. We have the fiducial inference analysis. We have the randomization tests. So we have the psychometric analysis. So as far as the quantitative data analysis is concerned, a researcher is having a whole lot of options with the help of which the quantitative data can be analyzed. Whereas in case of the qualitative analysis also, a particular researcher is having the luxury to choose, pick and choose from different options. So the researcher is having the constant comparison analysis as an analytical tool. Within case and cross case analysis, they have interpretative phenomenological analysis, which is the IPA for the phenomenological studies. They have the hermeneutics, which basically uses the hermeneutic loop to complete the cycle, give a very holistic kind of a view to the analysis. Content and thematic analysis, these two are the two most popular analysis we can see in the qualitative data analysis protocol. Narrative and discourse analysis, and then we have something which is called the case studies. Okay. Now, what are the real challenges? You see, a mixed data analysis, it might involve any of the 58 classes of the quantitative data analysis at a given point of time. If a particular researcher is to choose from one particular data analysis technique, so he or she is faced with 58 different classes of quantitative data analysis approaches and 60 different classes of qualitative data analysis approaches. So the number of combinations will be more or less 3,480. And it will be really confusing for a researcher to choose from this huge amount of different kind of analysis, which will be apt for his or her study. Now, when I'm talking about these 58 classes of quantitative data analysis approaches, I have only taken into consideration the parametric tests. I have not taken into consideration the Bayesian analysis or the psychometric analysis or the experimental randomization, etc., the non-parametric case. So if I consider the entire gamut of the quantitative data analysis, this combination, these options for a researcher will be exponential. It will be huge. But if I stick with the parametric test, and with the qualitative data analysis approaches, this comes down to 3,480. Now, from the integrative point of view, if we see the evolution of the integrative thinking in mixed data analysis, a number of researchers have proposed several integrative strategies. Like Caroselli and Green in 1993, when the mixed method research was at the germinating stage, it was still incubating. At that time, Caroselli and Green proposed this kind of strategies which focused on data transformation, making data amenable for a mixed method analysis, the typology development, extreme case analysis, data consolidation, or the merging of the data. Then later we have, contributions from Baksi and Tetley in 2003, exactly after 10 years from Caroselli and Green. Then again, after 10 years, we have Baksi and Combs coming out with certain specific data analysis protocol. And they focused on data reduction, they focused on displaying the data, talked about transformation of the data and make it fit for the analysis, correlating different kind of data that is churning out of different kind of method being applied, consolidating data, comparison of the data that are coming out from the different methodical approaches, and integrating data. Now, before coming to this concept of non-crossover data and the crossover data analysis, the mixed data analysis, basically, we can conceive it as a combination or a summation of non-crossover and crossover data analysis. Now, what is a non-crossover data analysis? Non-crossover data analysis is also sometimes known as, or it is alternatively known as, if I may say so, as the horizontal data analysis. In the first session, I gave you a little hint about the horizontal data analysis. Horizontal data analysis is basically that analytical technique or that analytical approach whereby qualitative techniques or qualitative tools are applied on qualitative data, and the quantitative tools or techniques are applied on quantitative data. And these two analytical processes take place concurrently. So when we say horizontal, by horizontality, I mean the parallel applications of these two data analysis. So qualitative data analysis techniques on qualitative data, and quantitative data analysis techniques on quantitative data. You see, in a non-crossover data analysis, which is also called the horizontal data analysis, there is no intersectionality. There is no intermixing of these techniques, analytical techniques. Okay. So that was, as I have told you in the first half, in the first session, that to a certain extent, this has been heavily criticized by the researcher, that it was not providing them with that required insights into the data, which is supposed to be one of the plus points, or one of the rationalities, or one of the logics based on which a researcher is applying the mixed method research, or is adopting a mixed method technique. So in 2015, two researchers, Anthony Onwig-Bussey and John Hitchcock, came out with a paper in the Journal of Mixed Method Research, published by Sage. In that journal, they proposed a process which is called the crossover data analysis. Crossover data analysis, or the vertical data analysis. In a crossover data analysis, what Onwig-Bussey and Hitchcock said, that to ensure intersectionality, there has to be a provision of cross-application of analytical techniques. Cross-application of analytical techniques irrespective of the structure of the data. So what they suggested in their particular paper is that in a crossover data analysis, apart from the qualitative and the quantitative analytical techniques applied on qualitative and quantitative data respectively, there has to be a provision of applying qualitative data analysis techniques on the quantitative data, as well as quantitative data analysis on the qualitative data, so that the nature of the crossover or the issue of intersectionality is addressed. So in 2015, Onwig-Bussey and Hitchcock came out with that concept. That was a very theoretical concept they came out with. And from 2015 to 2020, over the period of next 5 years, they actually used this theory and tested the theory in various perspectives, in various contexts. They conducted study in the healthcare industry. They conducted study in certain social phenomena, in the context of certain social phenomena. They conducted analysis in the tourism industry. They conducted a study in the entertainment industry, particularly the service dominant industries, the two where the application of mixed method research is much more validated. And within a span of 5 years, from 2015 to 2020, Onwig-Bussey and Hitchcock conducted multiple studies on the basis of their proposed theory of crossover data analysis. And in 2020, they went back to the same journal, that is Journal of Mixed Method Research, published by Sage. And now, on the basis of all these studies and the results and the outputs, etc., they refined their initial theory, which they published in 2015. And now in 2020, in the same journal, they proposed the CAF, the Crossover Analytical Framework. So this is something which has been developed very recently in 2020, in the month of July. We are yet to see, we are seeing 1 or 2 instances of application of crossover data analysis framework, but we are yet to see massive adoption of this crossover data analysis. So as I've told you, in case of a non-crossover data analysis, what we have, what essentially we have in place is qualitative monoanalysis and quantitative monoanalysis taking place simultaneously. So qualitative analysis on qualitative data and quantitative analysis on quantitative data. So this is also known as the horizontal data analysis. And why this term horizontal has been used? The horizontal term is indicative of this parallel application of these two different data analysis on two different differently structured data. Okay. Now, if I compare this with the crossover data analysis, you see the crossover data analysis is much more complicated, and as a result of which it is also called a vertical data analysis, because it is taking place concurrently and it has the cross applications of the analytical techniques. So it is not only quantitative analysis of the qualitative data or the qualitative analysis of the quantitative data, it is also the quantitative analysis of both the qualitative and the quantitative data, and the qualitative analysis of both the quantitative and qualitative data, and the summation of all these. Okay, so it is much more complex in nature. Okay, so if you want to read this particular paper, Crossover Data Analysis Framework by Anthony Onwig-Lucy and John Hitchcock, which was published in 2020 in the Journal of Mixed Method Research, Volume 14, Issue 1. This is probably freely available on the internet. If you can search, you can download it, because this should be one of the reference notes for all those researchers who are interested to pursue mixed method research in their research work, or they want to supervise their scholars who want to adopt mixed method research work. Now, one interesting thing about this mixed method data analysis, one particular study, 2 or 3 particular studies were surfaced during the 2007, 2008, 2010, 11, 14, 15. During that period, early part of the 21st century, in the second decade of the 21st century, a lot of social scientists came out with this particular opinion that while analyzing data, particularly the qualitative data, when the research participants are involved in providing response or providing data to the researchers in the form of interview, in the form of answering to the interview questions, or when they are involved in a group discussion, or when the researcher is adopting an observational technique, either a simple observational technique or interventional observational technique, when the researchers are taking field notes, or if it is a phenomenological study, say bracketing it out and studying the phenomena in purity, or contextualizing the phenomena according to the Heidegger's principle, whatever the format of the study, one thing the researchers have pointed out during those studies between 2005 and 2014, that a lot of researchers tend to ignore the non-verbal communication as data input. Okay, in the mixed data analysis, we constantly focused on either quantitative data or qualitative data, which are very apparent and which are almost taken for granted, that either of these two methods, if they are applied, they are supposed to generate this kind of data. If we apply quantitative technique, it will generate quantitative data, numerical data. If we apply if we approach with qualitative kind of data collection technique, it will churn out the qualitative data in the form of text data, image data, video data, audio data, like that. But very rarely, the researchers have focused on the non-verbal data that is coming out, data which are generated with the help of gestures and postures and body languages, etc. So Onwig-Lucy and Hitchcock also said, if a particular mixed method researchers want to analyze the entire gamut of data, these non-verbal symbols or these non-verbal cues are to be integrated in their data frame also. So, an NVCA was proposed, the non-verbal communication analysis was proposed also, although we see a very little application of this NVCA till date. But gradually we are seeing this NVCA being applied. Particularly, I can refer to a few papers who have tried to understand the use of emojis and emoticons in the message transaction process over the digital communication channels. Those are papers with a lot of insights into human psychology, use of nonverbal communication. So this is also another area that we should try to address and understand, because most of us tend to ignore this particular part. So when Onwig, Baksi, and Hitchcock proposed a framework for the nonverbal communication analysis, they identified several, you can say, terminologies which basically can be explained to identify what kind of nonverbal communication it is. Like proxemics is one of the terminologies that they have used. That includes the physical distance between the researcher and the participants, or among the participants. So when you are conducting an in-depth interview, or if you are conducting a focus group interview, what is the physical distance between the researcher and the participants, or among the participants in case of an FGI? That is an important cue that provides the interest or the eagerness or the involvement of the research participant in the research, in this transactional dialogue altogether. Then we have the chronemics, the use of pacing of speech and the length of silence in conversation. They said, Onwig, Baksi, and Hitchcock said that this is very critical, because they have seen that in the process of an interview, if a researcher is throwing a question, there are times when an instant answer is generated and the length of silence in that conversation is minimum. But there are certain questions when the research participant is pausing, taking time, thinking about how to, construct the answer in his or her mind, and then coming out an answer. That pacing of the speech and the length of silence, or the length of pause between hearing the question and coming out with an answer, is known as chronemics. And that also gives certain insights about the psychological orientation of the person who is participating in that research process. Then we have kinesics, which involves the body movements or postures which has certain definite meaning. We have haptics, which involves the use of touch. The paralinguistics includes all changes in pitch, in volume, and the quality of the voices. We have oculesics, involves the use of eyes by the participant, particularly your eyeball movement, the contraction and the dilation of the eyeballs, etc. We have the olfaction, involves the kind and degree of smell being detected. In case of these oculesics and olfaction, I can give you one example. The studies which are being conducted nowadays to have an understanding about the consumer behavior with regard to visiting the malls or the hypermarkets or the supermarkets. Okay, a lot of these oculesics and olfaction kind of inputs, data inputs are tapped. And there are a lot of gadgets with the help of which these oculesics and olfaction are this kind of inputs can be tapped. I am giving another example, particularly industrial research, which involves study of impact of advertisement or the commercials. Okay, whether an advertisement has much impact, whether the advertisement has highlighted the brand effectively, whether the advertisements have connected with the target group of customers, etc. A lot of oculesics cues are examined, whereby now these are used mainly in the experimental setup, whereby a group of selected people who were exposed to a particular commercials were allowed to use a particular optical device based on which they are allowed to go through a particular ad. So their eyeball movement can be tracked, which part of the advertisements have drawn most of their attention, where their eyeballs have contracted, where their eyeball have expanded. So overall, their ocular movement during going through a particular print ad or seeing a particular TV commercial, etc. So these researchers are finding these data inputs to be very important. We have Ekman's neurocultural facial expression that is also used. Ekman's model of neurocultural facial expression that was also used in several studies. We have gestation, which involves taste. Apart from Onwig-Buzzi and Hitchcock, we have seen the use of McNeil's classification scheme of 5 gestures. McNeil came out with this in 1992. He said that iconics or metaphorics, beats, and deictics, these and emblems. These are the 5 gestures which can be used as input data for the analysis, particularly in mixed method. Apart from the pure numerical, pure textual, these non-verbal communication is also are also to be included in the entire data frame. Then we have the cross-chain and Chawla's typology of non-verbal behaviors, whereby I said they are adapters which typically do not depict meaningful gestures, namely scratching of arms or scratching of hairs, or you have symbolic gestures, namely hand gestures like thumbs up or a very overt kind of a facial expression. You have conversational gestures, which are behaviors that accompany what you are actually saying. Okay. All these things, the mixed analysis techniques, it could be used to combine the analysis of the nonverbal and the verbal data. So when we talk about, the corroborate the speech narrative, we actually pointing out to the triangulation part. If we are, focusing on capturing the underlying message, we are focusing on the complementarity part. If we are focusing on discovering the nonverbal behaviors that contradict the verbal communication, that means you are saying something, but your body language is not supporting your verbal communication. There is an initiation. Remember, initiation in the first session, we told that initiation is something that focuses on contrasts, on contradiction, on breaking the existing molds and recasting the issues. So it can be one of the justification for conducting a mixed method research. So if you discover that the nonverbal behaviors are contradicting the verbal communication, that is one of the justification with the help of which we can go for the mixed method research, broaden the scope of the understanding, that's the development expansion part, and create new directions, that's the development part. So in the first session, we have studied all these as the justification or the logic behind the implementation of the mixed method research, like triangulation, complementarity, initiation, expansion, and development. And now we are just linking them with the analysis of the nonverbal data, because mixed analysis techniques, as we are now seeing, it is evolving. Not only a mix of the verbal communication in the form of generating, numerical data or textual data, it is also allowing us to tap the non-verbal gestures and integrate them with this traditional form of data, like the numerical or the text data. Okay. Now, this one of the things that I told you in the first session. One of the difficulties, rather, in handling samples, because I told you about the secondary dimensions of the mixed method research. In the secondary dimensions of the mixed method research, we said that in the secondary dimension, this sampling technique, that means whether the sample whether we should draw data from a single sample or multiple samples. If we go for multiple samples, then if certain issues arise which tantamounts to sample imbalance or heavily skewed sample, then what will happen? What measures we can take so that this sample imbalance can be smoothed out? Okay. Now, one thing you must remember fundamentally or essentially, that if a particular researcher is studying a population where the social phenomena that he or she is studying, or the phenomena that he or she is studying, or the issue that he or she is studying, is already naturally skewed. Say, for example, in one of the, while studying one particular social phenomena, in reality, it is heavily skewed towards the male population. So it is a male dominant social phenomenon. So if you are drawing sample from that particular population, and if your sample is showing a more male dominancy, then it is an obvious representation of the population feature. So that should not bother you. Although we face a problem that whenever we are applying certain techniques, particularly when we are trying to smooth out this sample imbalance, we take the help of different application tools and softwares. They will try to smooth it out, because otherwise, if we try to develop a model on the basis of this sample imbalance, it will be heavily skewed towards the majority of the sample. Now, to address this particular issue, handling the imbalance sample, we are now actually using this machine learning technique, which has become one of the essential features in this, data analysis, mixed data analysis. A lot of machine learning techniques have been introduced. So we have two different kinds of approaches. If you are faced with an imbalanced sample, you can either opt for SMOTE, which we call it SMOTE, the synthetic minority oversampling technique. And the second one is a near-miss algorithm-based undersampling technique. So these are the two sampling technique with the help of which these imbalance can be addressed. So what happens in SMOTE? Instead of going into the very complicated algorithm based on which these machine learning software operate, I'm giving you a very simple explanation. In case of the first case, synthetic minority oversampling technique, you emphasize on the term oversampling. When I say oversampling, that means, say, let us take an example. Say you have taken a sample of 50. Out of those 50, say 40 are males and 10 are females. So if you try to develop a model based on this particular sample, where 40 of the samples are male and 10 are female, if I try to develop a model, the model will be heavily based on this majority sample. Okay. Normally, when we run a machine learning algorithm, the machine learning processes assumes the majority sample as the base. Why it does so? Let me tell you. In the machine learning process, the data is bifurcated into training data and testing data. So normally what happens in a skewed kind of a sample, where there is a sample imbalance, the machine will not find adequate data for bifurcation in the minority sample. In this case, the females are only 10 in numbers, so the machine will not identify it as an adequate number of data where we can bifurcate into the training and the testing kind of a protocol data. Whereas with 40 samples in the pertaining to the male, they can easily divide it, say 70% for the training and say 30% for the testing. They can do it. So the entire model will be done, or entire modeling will be done on the basis of the majority sampling. So this imbalance has to be smoothened out. Okay. Now, if I want to smoothen this particular imbalance, then I have to generate synthetically certain samples for this minority group, so that the gap between the majority sample and the minority sample can be bridged. So synthetic production, if you are well aware about the bootstrapping technique, which sometimes is used in the regression analysis and in the structural equation modeling, it is almost similar. It is very conceptually similar to this. So there is a particular, technique which is used, which is called the K nearest neighbor application, or K nearest neighbor analysis. This particular machine learning identifies the nearest neighbor of the minority samples. What is the nearest neighbor? Means the feature that closely associated with the existing sample. The closest associates are selected. Actually, they are synthetically generated. And this is escalated. This particular minority group is magnified or amplified by synthetically producing the closest neighbors of these samples, and then the difference between the majority sample and the minority samples are being bridged. Okay, so we are artificially generating, or we are synthesizing additional samples for the minority on the basis of their closest features. Okay. In the second case, when we are using, or the machine is using a near miss algorithm undersampling technique, exactly the reverse thing happens. The reverse thing is, now we are focusing, now the machine is focusing on the oversample, the majority sample. Okay, and it reduces the majority sample and brings it very close to the minority sample. So undersampling is a technique where again we are using the k nearest neighbor application, nearest neighbor analysis, and we are trying to find out which are the nearest neighbor which are closely associated with this particular. Only the nearest neighbors are retained to a certain extent. The machine sets up a benchmark, and beyond that benchmark, all other samples are deleted. So we get almost an equally distributed sample. So one is, magnifying the sample, which is called the oversampling technique, and it operates on the minority sample. And one is the, concising, contracting the sample, which is operating on the majority sample, and thereby balancing out or smoothing out the differences between the majority and the minority sample. See, in case of a crossover data analysis, this technique is applicable, or we can easily apply that. Otherwise, when we used to have those non-crossover data analysis technique, whereby only qualitative on qualitative data, quantitative analysis on quantitative data, during those particular period of time, we did not have a sufficient tools and techniques with the help of which we can address these problems. So from 2015 onwards, and ever since this, data science had advanced a lot, this crossover data application, or the crossover data analysis, or crossover data analysis framework has been implemented. We have started to see the implementation of CAF nowadays, although, as I have told you, it is still at the neonatal stage. That means it is still, being experimented or not used to a certain extent. One thing over here has to be understood, that the application of the crossover data analysis, particularly when I say that the qualitative data analysis technique can be applied to quantitative data, and the quantitative data analysis technique can be applied to the quantitative data. This is possible due to something which we call the DSI, or the data structure interoperability. So data structure interoperability essentially says that irrespective of the structure of the data, analytical techniques can be applied. So on a very subjective data, you can apply an objective test, and on a very objective, very scientific, or very numerical data, you can go for a very abstract analytical process or a subjective analytical process. So irrespective of the structure of the data, that means structurally, I can change the data from one given format to another format very easily. So this DSI has been, this particular DSI is ensured, or interoperability is ensured, because I have this, advantage of machine learning. I have this advantage of advanced data analysis software nowadays, which ensures this DSI. Otherwise, CAF would not have come to the picture. So let us just take into account that what are the quantitative analysis which can be done on qualitative data. If you see this, apparently it seems unbelievable that how this is possible, because till date we knew that these are some of the analysis which cannot be done without a proper numerical or statistical set of data, and that too taken or obtained through a particular protocol, whether the data is normally distributed, whether they are metric data, etc., etc. So a lot of things are there to be considered before we decide on the quantitative analysis. So we have factor analysis, which is an interdependent technique. We have correspondence analysis for in that same area, multi-dimensional scaling techniques, again, cluster analysis. These are all interdependent techniques. Hierarchical linear modeling, structural equation modeling, Bayesian analysis. You see, even if I go for logistic regression, even logistic regression as a quantitative data analysis tool can be applied on the qualitative data. Say, for example, factor analysis. I will show you one hands-on application of the factor analysis on the qualitative data. You see, factor analysis, basically, essentially, those who are well known with this factor analysis. Factor analysis, very simply put, factor analysis help us to identify the underlying factor structure. Okay. Now, this is also a very confusing kind of a definition or a confusing kind of a concept. Let us understand it very simply. Say, for example, I want to measure the introvertness or extrovertness of a particular person. Okay. And it is very difficult for me as a researcher to have a direct measure of the introvertness or extrovertness. Or in other words, I can say that introvertness or extrovertness in a person cannot be directly measured. Similarly, there are many social phenomena, there are many other issues in our social world which cannot be measured directly. There has to be a process of surrogation. There has to be a process of indirect measurement. So let us go back to the initial example. I want to measure the introvertness or extrovertness in a particular person. So what I can do is I can actually observe the behavioral pattern or the expressed or the manifested behavior of that particular person. Okay, those can be observed. So you see, on the basis of those observations, I can conclude that this person is either an introvert or an extrovert. Okay, so instead of having a direct measurement or direct attempt of measurement of introvertness and or extrovertness, which is impossible, I am taking an indirect route. I am just observing the behaviors or the behavioral patterns. And then on the basis of my observations, I am concluding, I am interpreting that, okay, all these observations are tantamounting to either this person as an introvert or an extrovert. So in case of a factor analysis, we have a huge amount of observed variables, okay? The variables which are stated, the variables which are manifested, the variables which are measurable, the variables which are expressed. But our interest or our objective is to try and understand what lies beneath these stated variables. So as a researcher, my objective is to try and find out the underlying factor structure, okay, beneath these stated variables. What lies beneath these stated variables? So there factor analysis comes to play, okay. So factor analysis basically can be done. Till date, we used to believe that it can be done with the help of scaled data. Particularly, the scale should be interval in nature. So we take a Likert scale, a 5-point or a 7-point Likert scale, and that particular scale is fitted into a survey instrument. The survey instrument is having all those scale items, and we are taking a huge amount of data from the research participants. And then we are using several statistical, application tools. One of the most popular is SPSS, and we conduct a factor analysis, and we identify the factor structure. Now, if I want to apply this same analysis in a qualitative data, say, for example, I have got, say, 50 interview transcripts, okay? And I want to apply factor analysis on these interview transcripts. So all the interview transcripts are actually the text, okay, the narratives, the questions being thrown by the researcher, and the response have been generated by the respondents or the research participants. So it's a huge data set, 50 research interview transcript. So you see, when I'm applying factor analysis on this kind of a data set, what essentially I'm trying to do is, see, I am actually using the same principle of factor analysis, okay? What is the principle of factor analysis? Factor analysis helps me identify all those constructs which are hidden, which are latent, which are unmanifested, which cannot be measured, which cannot have a direct measurement. Okay, so that's the principle of this factor analysis. So while deploying factor analysis for qualitative data, the principle will say, if I apply the same principle, then what will happen? That all these narratives, all these interview transcripts are the expressed or the stated or the observational data. And I want to find out the hidden themes, the unmanifested themes or the latent themes that I can extract. Because you see, identification of the theme and the thematic connect will lead me or lead the researcher to develop the theory or to develop the hypothesis. Okay. So my objective in applying the factor analysis on a qualitative data is to identify the underlying themes in all these interview transcripts. Or, for example, a researcher may conduct, say, 10 case studies. And in these 10 case studies, the researcher wants to find out what are the different thematic output. So the factor analysis can be deployed, and the factor analysis will churn out all the themes from these qualitative data. Now, when we are using factor analysis for qualitative data, it is known as the FATM, the factor analysis topic modeling. Normally, the topic modeling is something which has become very popular in qualitative data analytical technique. We use a machine learning process which is called the LDA, the latent dirichlet allocation, which is very instrumental in conducting this topic modeling. So in a topic modeling, the topics are identified, or the topics as a latent themes or hidden themes are extracted from the text, from case studies, from FGIs, from interview transcripts. How it is identified? On the basis of, combination of the keywords, how frequently certain words have been used, how frequently certain phrases have been used, how frequently and how repeatedly and in what proximity these texts, these words, these phrases have been used. So this is one of the examples that we have taken in quantitative analysis of qualitative data. Another one is the logistic regression. Logistic regression is a well-known quantitative analytical tool. It is now used in the analysis of the qualitative data, particularly in clustering and classification. Okay, so we are seeing day by day the growing applications of the logistic regression in clustering and classifying qualitative data. Say, image classification and image clustering. These two are done on the basis of the use of logistic regression principle on this. So you have multiple number of images. As I have told you, that qualitative data essentially is not constituted of text data. Qualitative data is also valid for images. Qualitative data is, images are also considered to be qualitative data input. Videos are also considered to be qualitative data input. So if my research has a huge amount of image, and if I want to cluster those image, if I want to classify those image, if I want to categorize those image, and later on after classification and categorization, if I try to find out what kind of themes these images are churning up, so I can start with a logistic regression and then I can use the FATM model. So these are certain things which are gradually emerging, and in future probably we will see more and more applications of this particular technique. Next, let us see what are the qualitative analysis that can be done with the help of quantitative data. So we can have mixed method discourse analysis of the quantitative data. We can have quantitized narrative analysis, because narrative analysis is one of the most popular analytical tool which is used in the qualitative data analysis. We can have qualitative profiling of scaled data. Scaled data is a pure numerical data. We can have qualitative profile. We have qualitative coding of the scaled data. This is qualitative coding of the scaled data is a very popular method. Those who are well aware about the social media research, particularly the sentiment analysis, the network analysis, the SNA, the social network analysis, dealing with the Twitter data, particularly Facebook data streaming, Instagram streaming. There, a lot of qualitative coding is done on scale data. So if you have scale data, a lot of qualitative coding can be done. Ethnographic decision models, ethnographic studies or ethnographic analysis is one of the qualitative analysis. Digital ethnography on the digital platform, we are seeing that also helping us to develop the decision models. Then qualitative comparative analysis. This is another analytical technique which is being used on the quantitative data also. So gradually we are seeing these cross applications of data after 2020. Ever since this CAF has been introduced, the crossover analytical framework, we are seeing the application of these things. So mixed data analysis, if I apply the quantitative techniques on the qualitative data, this is one of the examples that we want to stick with today. As I have told you, at the end of this particular session, I will go ahead with at least one or two hands-on exercises. So let us take on this thing, application of quantitative techniques on qualitative data. As I have told you that these two things that I have discussed. One is this factor analysis, and the second one is the application of the logistic regression process in clustering and classification of images. So let us see how these two things can be done. One more thing is very essential to know over here. Since this particular session or this particular workshop did not give me a chance to showcase the use of the qualitative data analysis software, most of the qualitative data analysis software these days are having multiple number of plugins with the help of which you can conduct both the qualitative and quantitative analysis on the same platform. One of the most robust, analytical platform which I recommend is the QDA Miner. QDA Miner is basically a platform which can be used both for the quantitative study as well as for the qualitative study. Another one which I use very frequently, it's an open source software. Basically, it is based on R and Python, that is the Orange, which is also a very robust platform whereby you can conduct both the qualitative and the quantitative analysis. Okay, so QDA Miner and Orange, you can use the QDA Miner Lite. QDA Miner, basically, it's a proprietary software, so it has a certain cost associated with it. But fortunately, there is another version of QDA Miner which is called the QDA Miner Lite. The QDA Miner Lite is an open source one, so you can download it and all different kind of analysis. Particularly, the person who is interested in doing, qualitative data analysis, they can do so. For the quantitative part, as a standalone software application, most of us are using SPSS. Okay, but I am giving you another option. Which is again open source and free. If you are using JASP, the JASP, JASP, you can download it and you can do anything with all the different kinds of analysis, quantitative data analysis, regression, structural equation modeling, exploratory factor analysis, the descriptive analysis, the chi-square, t-test, etc. Everything, ANOVA, everything. The name of the software is JASP. So if somebody is not having access to SPSS, because we know SPSS is again a proprietary software and it is a very costly one. If we want to access all the modules, there are 26 different modules integrated in SPSS. It's not possible to have access to all the 26 different modules. And even if you want to purchase it, your university or college or institute wants to purchase it, they have to restrict to only 3 to 4 modules. It's very difficult to go for the entire thing. And after that, if you want to conduct the structural equation modeling or the path analysis and etc., confirmatory factor analysis, you have to purchase the additional plugin called AMOS. Okay. So one of the advantages of JSP over SPSSE is JSP on a single platform, on a single click, it will allow you to perform EFA, that is exploratory factor analysis, as well as confirmatory factor analysis. This is one of the unique features of JSP. But most importantly, JSP is open source and easily downloadable. You can install and start using it. So I will be using one open source, that is Orange, for image classification and clustering. And the second one is application of the latent Dirichlet allocation based topic modeling, or the FATM, the factor analysis topic modeling. For that, I will be using one particular plugin. This is a plugin for the QDA miner. The QDA miner has two plugins. One is called the WordStat. WordStat is basically for the content analysis. And the second one is a SimStat. SimStat is basically for the quantitative analysis. That's why I told you that QDA miner is one of those unique platforms which allow you to go for both the quantitative and the qualitative analysis together. There are other softwares also which are again proprietary in nature, like Atlas TI for the qualitative data analysis, NVivo for the qualitative data analysis, Max QDA for the qualitative data analysis. These are all proprietary in nature, but essentially, if you are using any one of them, if you see their interfaces and if you see their operations, if you see their nodes and the tabs and the icons and the functionalities, each and every software is same. Okay, and they are all running on the languages, the high-end machine learning languages, or these machine learning protocols. They are using almost all the things are same. The networking facilities, the coding facilities that they're providing, the modeling facilities that they're providing, the clustering facilities that they're providing, frequency distributions that they provide, they all are same. Okay, so if you can stick with either of any one of these particular data analysis software, it will do wonders. There is one open source qualitative data analysis software which is called the AQUAD, AQUAD. AQUAD, that is, but I have seen AQUAD. It's not that user friendly. I strongly recommend you to use QDA miner Lite. If there are certain difficulties in using QDA miner Lite, you can go for the Atlas TI trial version. The Atlas TI trial version is a permanent trial version, which is having one unique feature that it can be updated. Very rarely you will find certain software in its trial form can be updated to the latest platform. But Atlas TI is that unique software. In the trial version itself, it is offering you the provision to update it. But one slight disadvantage, and that will be acceptable, that it will handle a maximum of 10 to 15, probably it's handling 15 documents, and the number of codes that you can create is also limited to say 30, 50, like that. But you can have multiple set of data and multiple set of projects. If you are writing a paper, instead of writing, if you are not writing, if you are not focusing on the entire thesis, if you are writing a paper for the journal, I think the trial version of Atlas TI is more than enough. Okay, so let us just take a look into these two things. One is the image classification and clustering using Orange, and one is the latent Dirichlet allocation based topic modeling using the WordStat. So these two will be the two small hands-on demonstration which will end this particular session. So I will just show you one thing. Probably some of you have already used Orange, or I do not know. So what you can do is you just go to Google. Those who are interested, orange software. So this one, orange data mining. Okay, so if you click it, it will allow you to download, and you see there will be a download button over here. You download orange and you can use it. So since I have already downloaded it and installed it, so I'm directly opening it up. See, this is the desktop icon of orange. So if I click it, it will open up. Okay, so the initial screen or the initial interface of the orange looks like this. So you see, on it, it has three things. One is this left-hand side navigational, vertical navigational panel, which contains all the widgets. It's basically a widget-based, analytical platform. Widgets means you can actually draw and drag these widgets. This is the working space where you can draw and drag these analytical widgets. Then actually what you can do is you can actually connect these widgets. See, these widgets are to be logically connected. The moment you are connecting two widgets, the analytical process is taking place automatically. So if it is a logical connection, if it is a justified connection, then the analysis will take place. If it is not a logical connection, you will find a small red cross or a red multiplication sign appearing over here, indicating that this is not a logical connection and this operation cannot be carried out, or this analysis cannot be carried out. So all these icons which are depicted over here are known as the widgets. So in what is our objective as a researcher or as a data analyst? We are supposed to bring all the relevant widget, and we need to set these relationship or the linkages between the widgets, which will lead us to the analysis of the data in our hand. Okay, so let me just delete it. Now, for the first time user of the orange, you see in the left-hand side navigation panel, if I scroll down, the first panel is the data panel. So you have related to data all these things. So all the quantitative data analysis can be done with the help of this particular panel. Then we have the visualizers. One of the advantages that we now have with the help of all these data analytical software, one of the biggest advantages is we can visualize our results or the output in a much better way. This is to a great advantage of the qualitative data researcher. Qualitative researcher particularly, for the quantitative researchers, they always had this advantage. Okay, the graphical representation, graphical plotting. So visualization was never a problem for the quantitative data analysts. Visualization was a problem for the qualitative data analysts. So what these new qualitative data analysis software has brought into the picture is the ability of a researcher to visualize the data and present it in a visual mode so that it becomes more interpretable. It becomes more apprehendable. Okay. So this is the visualization window. So you have all different kinds of visualization tool. You have a heat map, you have a tree map, you have a box plot, you have a whisker plot, you have a scatter plot. You have the Shilute analysis, which is used for the clustering process. You have a histogram and a homogram analysis plot, all these things. Then you have different kinds of models. Okay, the regression model, the KNN, the K nearest neighbor model, the logistic regression you can see over here. Then you have the curve fit, the linear regression, all these things, all these models are also over here. You can evaluate different kinds of things. Unsupervised learning mechanisms you can have over here. I will be using this as a demo, the image analytics area. And then there are bioinformatics. There are lots of things. So you can go for this text mining. This you see, you can drag and drop for Twitter analysis. Anybody interested in social media analysis, if they're interested in Twitter analysis, they can drag and drop this particular widget, connect it to your Twitter handle, and stream in the Twitter data. Over here, you can see sentiment analysis can be done. So a lot of things can be done on a single platform. Okay, this is one of the advantages. You have the network analysis over here. You just click on and it will give you everything. Spectroscopy can be done over here. You can go for time series analysis over here, the geographical data analysis over here, and the geo tab. Okay, so you can have a host of different kinds of data analysis. So I consider Orange as one of the, and Orange is coming out with updated version almost every month. So new and new features are being added on a very regular basis. Now, one thing I want to say to you all, when you are using Orange for the first time, you will not get all these options. Okay, so you can ask this question, from where I can get all these options. You just simple click option. Okay, so in this horizontal ribbon, you will find one particular tab over here, which is called option. You simply click this option and you simply click this add-ons. Okay, now add-ons will allow you to apply all these features. Okay, and you will find that it is basically calculating, it is basically estimating what are the features that I have already installed. That means I have already the add-ons over here. See, all these add-ons are already there. Okay, so if I just click this, in your case, probably these will be unchecked. Okay, these will be vacant boxes. So you just click these boxes and click OK. Okay. So for the time being, I am pretty happy with whatever I'm having. So I'm just closing this particular box. Okay. So don't be confused if you see a very open platform or a, absolutely vacant navigational panel over here. What you need to do is to go to the options, you click on the add-ons, and then identify all those things you need to add. So all those issues, say image analytics will not be here initially. So you click on this particular box and click OK, image analytics will be automatically integrated. Okay, now let us just take up this analysis, image classification and clustering. Okay, let me just show you with the demo set of image. Okay, so let me have some images. Okay, so I have 3 sets of flowers, images of flowers. So these are lotuses. There are 5 pictures of lotuses. There are some pictures of marigolds, and there are some pictures of roses. Okay, so we have these random pictures taken from the internet only, and I want to classify and cluster them. So every marigold will be clustered into one cluster, all the roses will be clustered, and all the lotuses will be clustered. So if the machine can predict each and every image properly, then the clustering process will be done effectively. Okay, now to do this particular analysis, see, the underlying principle or the underlying analytical technique for this image clustering is the logistic regression. Okay, but we are applying logistic regression on what kind of a data? On very subjective qualitative data, because they are all images, they are not numerical data. Okay, so let us start. So I come to this particular tab called image analytics, and the first widget I want to drag and drop over here is called the import images. So if I double click it, it will allow me to browse and show the path of the images. So I'm just clicking it and selecting the folder. And you see over here 20 images under 3 categories. 20 images have been loaded. So I just close it. Now I want to see what kind of data these images have. Okay, if I want to see what kind of data these images have, if I want to represent these images in data form, what kind of scenario it will be. So I have dragged and dropped this data file in this particular canvas, and I am linking this. So what I have said, if the linking is logical, then the analytical process automatically takes place. So if I click the data file, it will open up. You see what kind of data it is throwing up. It is showing the size in pixel, width in pixel, height in pixel. These are all very, you can say, meta information. With the help of meta information, we actually cannot run a machine learning algorithm. Okay, so the machine learning will not be applied on this meta information. What I need as a researcher is the image descriptors, okay, that can actually describe the content of the images. Okay, at present we do not have it. So I have another option. Okay, let me go back to the image analytics. One of the tools that I will be using over here is called the image embeddings. Okay, so I am dragging this image embedding over here, and I am again linking the images, import images with the image embedding. Now, what is image embedding? See, as I have told you, in case of a data table, what we have seen is the raw images, if they are translated or transcribed into data form, what we are getting only the meta information about the images. We are not getting the content descriptors. Okay, so meta information is not enough to run any kind of machine learning process. I need, as a researcher, the descriptors, the content of the image that is describable. So numerical content descriptors of those images. So what this image embedding will do, the image embedding will transform the raw images into their vector representation using the deep neural network, which was trained on millions of real life images. Okay, don't have to go into details of these technicalities. Only you understand that to interpret the image in a better way, we have to connect the image with the image embedder. So the image embedding takes place, and the retrieve vectors are also called the image embeddings. Actually, the vector, the raw images are converted into their vector representations, and these retrieve vectors are called the image embeddings. Okay, so now if I again say add a data file, data tables. Okay. So if I again attach a data table over here after embedding the images, now you see how the data table looks. So I want to show you the initial data table. You see only the size, width, and height. Nothing else was there. Okay. Now see after embedding. You see size, width, and height. Now see the image descriptors. Huge number of image descriptors have been generated, which talks about the basic content, the texture of these images. Now, this particular data is suitable for the machine learning. Okay, so until and unless we are actually using this image embedding process or image embedding protocol, it will not make your image ready for this quantitative analysis. Okay. So we have already done this image embedding. Now what we want to do, we want to cluster, we want to classify, we want to see. So hierarchical clustering process. So from image embedding, we follow, we want to attach it with the distances. Okay. from the distances, because this we are gradually shifting from the qualitative data and we are applying this quantitative technique, and we are applying the hierarchical clustering. Okay, so this is our ultimate objective, to identify the cluster. Okay, now you see, as I have told you, if the connections between the widgets are very logical in nature, we will not have any hamper or such kind of cross symbols which say the operation could not take place. These operations have taken place, so I want to click these hierarchical clustering. You see these clusters have been identified. Okay, so let me click one or two clusters. Okay, so I have selected this cluster, and if I attach it with the image viewer, now see the selected cluster, all are roses, isn't it? Rows, 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 rows. So the selected I have selected one cluster, this one, this one. So all the selected clusters are roses. So the machine have predicted, the predictive model has hold good. For the roses, at least, all the roses have been predicted nicely, that all the roses are clustered into one. So there the machine has classified the flowers on the basis of their image descriptors, which has been done through image embeddings, and they have clustered into one group. Now, is it true for all the flower category? That I have to check, isn't it? That means whether all the marigolds have been clustered into one, all the lotuses have been clustered into one, that I need to check also. So for that, what I can do, I can actually go for this logistic regression. Let me bring out this logistic regression now. Now, from logistic regression, I will be attaching this logistic regression to generate a confusion matrix. And let me see whether the machine is confused in predicting and classifying the flowers. So from these image embeddings, I am drawing another link, which is going for test and scores. I will be identifying the test and scores related to the embedments. And I am connecting logistic regression with this test and score. And what will be the output? See, the test and scores have been calculated. So the logistic regression is taking it forward. And the output will be the confusion matrix. Okay. Now, what is the objective? Let me just repeat this entire thing, what I have done over here. That I have identified that some of the flowers which belong to the rose family have been clustered nicely. So all these flowers have been identified properly. Now I want to see that whether all the flowers of different categories like marigold and lotus, whether they have been identified in a proper manner or not. So I have deployed the logistic regression to generate a confusion matrix to identify whether the machine is confused, whether the algorithm is confused to identify the clusters properly or not. So what this confusion matrix will churn out? The confusion matrix will churn out whether all the flowers have been predicted properly to belong to that particular category. So whether all the marigolds are clustered as marigold, whether all the roses are clustered as roses, whether all the lotuses are clustered as lotuses. So let me just open this confusion matrix. It looks like this. So you see, say it is a matrix, so it will have a 3 x 3. That means it's a 9 cell matrix because we have 3 groups of flowers: lotus, marigold, and roses. You see, in the first case, if we go back to our data, how many lotuses were there? 1, 2, 3, 4, 5. You see the result. Out of 5 lotuses, 4 lotuses have been predicted properly by the machine. That means 4 have been identified as a lotus. One particular lotus have been identified as a rose. Okay, so there lies the confusion. Probably the configuration, probably the picture itself, the color contrast, etc. The machine could not identify it as a lotus. Okay. In case of a rose, there were 10 pictures of roses, and all the 10 pictures have been identified as a rose. So it is a perfect prediction, perfect clustering for the roses. Unfortunately, in case of marigold, you see, there were total 5 marigold pictures, out of which only 2 have been predicted as marigold, and 3 have been classified and predicted as roses. So here the machine have got confused. Probably with the structure of the picture, it were not as distinct, picture compared to that of a rose, and say the petal distribution, the colors, etc., etc. So the confusion matrix is very important, because when you are reporting these things, for most of us, we are very much interested to report the cluster. Okay, the cluster is good, but the cluster, whether the quality of the cluster, whether the quality of the prediction is also good, for that you need to have multiple analysis. One of the analysis is this confusion matrix. Another thing that we can identify particularly for this, if we go for Shilute, okay, let me go for Shilute analysis, Shilute plot. Okay, so you see, in 1972 probably, or 73, there was a person by the name Russo who came out with a concept of qualitative understanding of the clustering process, because a lot of things were thrown at that particular point of time regarding hierarchical clustering process. And as soon as a cluster is identified, say a particular researcher is coming out with a 4 cluster model or a 2 cluster model, whether those clusters are good enough or whether those clusters are having quality can be designated as a quality cluster. So Russo came out with a technique which is called Shilute analysis. Shilute analysis is a representation of the quality of the cluster. So there is an axis over here, you see at the 0 point. On the left hand side, all the negative plots are plotted. On the right hand side, everything that is plotted on the right hand side of the 0 is considered to be a robust cluster or acceptable cluster. So over here you can see only the lotus 4 out of 5 and rose 10 out of 10. Those are having almost robust prediction and clustering. You see, this is basically the red one is the marigold. Unfortunately, in case of a marigold, out of 5, 3, that means 60% prediction was done wrong. So as a result of which the clustering was also wrong. So Shilute will give you the concrete idea of which clusters are to be retained and which are to be reported. Okay, so always conduct a Shilute analysis, which will give you a better result. Now, for better visualization, you can add on lot of visualization. I can go and add this, what is called the heat map. You can generate the heat map also. If I click it, it will generate you see the heat map along with the clustering process. So you can go for multiple number of data visualization based on a single analysis. See, our initial analysis on this was image classification and image clustering. So we have seen that certain clustering or certain classification has come up. Then we have also cross-checked that whether all the clusters are good for reporting. We have seen no, out of 3 clusters, only 2 can be retained and 2 can be reported, because those 2 are found robust enough for report. Okay, so this is one of the application. You see, I have used logistic regression categorically to create the confusion matrix to judge the quality of the cluster. For what? For not the numerical data. Although I may say here, or you may say here, why it is not a numerical data? Because the moment we have embedded the images, the subjective data have been transformed into an objective data. It's quite true, because all the data analysis software which analyzes qualitative data, please remember, the underlying principle of analyzing the qualitative data is how the qualitative data can be quantified. This is number one. And number two, in most of the qualitative data analysis software, the surface level analysis, the frequency, the word cloud formation, etc., whatever is done, the code co-occurrences, code similarities, code frequency distribution, phrase distribution, code to phrase connectivity, all these things are done on the basis of the lexicon integrated with the qualitative data analysis software. What is a lexicon? Lexicon basically is the dictionary. So all the words are cross-checked with the dictionary attached with the qualitative data analysis software, and then they are projected in that particular form. Identification of the keywords, identification of the word clouds, etc. So either for a deeper analysis, we have to convert the qualitative data into quantitative data. That means, in other words, we can say we have to identify the vector representations of the qualitative data, and then we can go ahead, because the machine learning or the software take the analysis from there only. Okay, so that can be done very easily. So that is one of the examples that I wanted to share a little, hands-on with the help of Orange. Orange is, as I have told you, is a very robust platform. So any one of you who are doing purely qualitative data analysis, text mining, where text analysis, etc., image analysis, etc., is a requirement, they can use Orange. Most of the researchers who are doing mixed data analysis, etc., they can use Orange. And why I recommend Orange? Because Orange is an open source and free to download and install, and very easy to use. Everything is guided. Okay, so you can use Orange very easily. Okay, let us come to the second application. As I've told you, this will be the last one. It is the application of the factor analysis topic modeling, or the FATM, by using one of the plugins of this QDA miner. Okay, so let me just open this. See, WordStat can be opened as an isolated or a standalone application, or you can open a WordStat from QDA miner also. So it's your prerogative from where you will be opening. I am just running this WordStat as a standalone application. So this is where my cursor is hovering. This is the icon of the WordStat. So let me just click and open it. So what I will be doing is I will be using WordStat to identify the themes or the topic from a data set, and that data set contains certain FGI, that means focus group interviews, and case studies. Okay. Oh, I forgot to explain. So let me start from the beginning. So this is stat. You see, the interesting thing is the first window. Okay, so over here you will get certain option like create a new project, or open an existing. If you're already having a project, you can open an existing project, or reopen a recently closed project, whatever you want to do. So I want to create a new project. I'm just clicking it. Create a project from a list of documents. Yes, I am interested to create a project from the list of documents. So I'm just clicking this also. So you see, it has taken me to that particular folder, which contains all these case studies and these FGIs. Okay, so let me just select it. The simple is select, very simple. So you select it and shift and pull it down. So you select the entire data set. Probably there are 23, including FGI and case study. I forgot the exact number, but probably. So once you select all these data set, you just simply click this icon, which is telling you to add. So just add it and click OK. Okay. Now you see there is an option. Option is if there are certain images, you have taken certain pictures when you are doing case studies. You see, most of us are tempted to take pictures, or when you are conducting focus group, we normally take picture of that focus group. So there can be images associated with those text files. So you, under normal circumstances, you should retain those images. But over here, because image import, it will take certain time. So I'm just clicking on the remove images. So I want to export the data set without the images. Okay, so it will save us some time. So I have clicked on this particular box, remove images, and I have clicked OK. So it will prompt me to save it, because this particular operation will not run until and unless you save it. So demo_save. I'm just providing it a random name. So you see all these data have been ported. Okay. So see, these data are not coded. So I'm not interested to go for that particular qualitative data. I'm just focusing on to identify the themes. Okay. So I have not coded it. I have not done anything. No processing of this data. It is imported as it is. I have just got rid of the images. Otherwise, the file will be quite bigger for import. So all the data have been imported in this particular platform. So there is a green button over here, which is called Analyze. You just click this Analyze. So I will be analyzing this entire file and the document. And essentially, or preferably, you select this expert mode. So you just click on this expert mode and you click OK. So let me just save this also. Okay. Now you have the platform ready. Okay. So there are multiple number of tabs over here. You see the text processing over here, frequencies, extraction, the code co-occurrences. So once you code it, you can do the co-occurrences from here, the cross tabulation, the classification, the keyword in the context. You can do a whole lot of a test using this WordStat device with this particular platform. What we are interested in topic extraction. Okay, this is a topic modeling, factor analysis, topic modeling. We want to extract the topic. The topic are basically the themes, the latent themes. The data that we have imported over here are the manifested or the expressed data in the form of cases, in the form of FGIs. So we are clicking this particular option, which is called extraction over here. Okay, so we are clicking this. Now you see that number of topics that have been identified and that can be extracted is 7. Okay, it is written over here. And we will simply click this run, this green button, which is called run. So first we are clicking this extraction and then this run. So we are just simply clicking the run. Fine. So you see, these are the 7 topics, or these are the 7, themes that have been identified on the basis of what? On the basis of the keywords which are associated with this particular topic. Now, 2 scores are very important. You see, a lot of criticism initially in the first session, we said that the people who are practically doing the quantitative research, they have undermined the qualitative researchers by saying that your research is very biased. You do not have very objective interpretation. It doesn't allow objective interpretation. You do not have scientific results, etc., etc. But nowadays, see, I have started, analyzing the qualitative data, the text data. Now we have got the statistical, results to support these qualitative analysis. So no longer it is a very vague, very biased kind of a thing. It has a objectified or a very objective driven kind of an analogy, which is equally good for the quantitative approaches. So if I compare it with quantitative approaches, now two scores are very important when you are reporting, theme extraction or FATM. One is called the coherence score. You have got the eigenvalues over here also, the coherence score and the perplexity scores. Perplexity scores are not displayed here. It is not required actually. In other platforms, you will find both the coherence and the perplexity scores will come up. What the coherence score says, to what extent the keywords extracted and the topic that has been identified are interrelated with each other. Okay. So, and what is a perplexity score? You see, the interesting part is, since the perplexity scores are not there, the relationship between the coherence scores and the perplexity score is higher the coherence score, lesser will be the perplexity score, and vice versa. So what does the perplexity score says or denotes or imply? The perplexity score implies to what extent the machine has become or has got perplexed in identifying a theme and associating it with their keywords. Okay. Say, for example, this first topic that has been identified is called the vested land based on these keywords, which has received a coherence score of 0.608 out of a maximum coherence score of 1. Okay. So the perplexity score over here will be quite low compared to the last topic, which is the NGNB patta holder, which is this particular topic related to these keywords. Here, the coherence score is 0.361. Okay, so I do not know. Probably for other topics, if we have more number of topics as we go down the scale level, probably the coherence score will be much smaller and the perplexity score will be much higher. So higher the perplexity score, it means the machine has got very confused, very perplexed that whether this group of keywords can be exactly denoted by this particular topic or not. So as a researcher, you can set a cutoff value. Like in case of factor analysis, we normally fit a loading, the factor loading value to say 0.6, below which we all discard. So over here, you can actually set a particular, coherence score value. Say I will accept anything which is above 0.04. So you can actually accept, 1, 2, 3, 4, 5. This 5. Oh, sorry, 1, 2, 3, 4, 5, 6. These 6, things, topic you can accept, because the last one is 0.361. So it is below 4. So that all depends on you. Okay. So if you see the co-occurrences, probably it will not take place over here because I haven't codified it. But you can check the cross tabs also over here based on all the keywords that have been identified or extracted while the topic has been framed. So these are certain things which we can do better compared to what we used to do earlier. See, this FATM that we have conducted over here, or the factor analysis principle that we have applied over here, it is basically using the same factor analysis principle that we have used in our pure quantitative processes. So this is an LDA based factor analytical tool, which you can use particularly for qualitative data analysis, and it is a very essential tool for the factor extraction. Those who have already, for those researchers who are present over here, if you have already used NVivo as a research tool, I do not know how many of you are exposed to NVivo. NVivo also extract themes. Now the extraction of themes by NVivo is done on the basis of this factor analysis process, where you will only get to know the details of the extracted themes based on the identification of the keywords. Okay, so these are the two techniques. There are lots of other techniques which can be used in the mixed data analysis, and in the near future, probably you will find that all these things will be used to a great extent. And we are seeing actually the research protocol, particularly from the analytical point of view, is changing very rapidly. The horizons are changing very rapidly. So if you are keeping a very close track of the papers which are using mixed method research, you will find that newer applications in the data analysis area will be surfacing. So we it's very interesting to take a note of that, and we will keep on tracking what new things are coming up. But in the next 5 to 6 years, there will be a lot of changes in the data analysis system overall. So thank you very much. We can stop over here.